So once again, this is the trapezoid or the trapezium rule. So this is just a notation or a formula that we can use whenever we wanted to apply this particular rule. All right. So let's try to come up with some patterns, a general pattern on how the trapezium rule is being done. So previously, we were able to approximate the area of a curve using 5 trapezoids, and that area will just be equal to this. Now, how about if we instead had it using 6 trapezoids? So if you try to look at the pattern, y sub 0 here will be the first length, y sub 5 here will just be the last length, and the rest is found in between them. So we can just simply assume that with 6 trapezoids, the trapezium rule will just be equal to this. Pause the video if there's a need for you to be able to analyze. So that's still half of the width or the height. It's up to you on how you would want to see it. You have y sub 0 times y sub 6, y sub 0 plus y sub 6 plus 2 times the length in between them. All right? Up until the last length, which is previous to, up until the length, which is previous to the last length, y sub 6. So that's 2 times y sub 1 plus y sub 2 plus y sub 3 plus y sub 4 plus y sub 5. Now, how about if we have 7 trapezoids? So again, we can assume that if there are 7 trapezoids, using the trapezium rule, the notation will just be this. Pause the video and try to analyze. Now, what if there are n trapezoids? Because technically, we cannot put a boundary as to how many trapezoids we can make. We can use more than 10 even, depends on the use or depends on the convenience. So if there are n trapezoids, the general trapezium rule or the general notation for the trapezium rule would now be half of x times y sub 0 plus y sub n meaning this is now the last length, plus 2 times y sub 1 plus y sub 2 plus up until y n minus 1, meaning the length which is the one before the last length. That's why we had n minus 1. So if there are 7 trapezoids, this would be the sixth one, 7 minus 1, the sixth one, just like this. All right, and this, my students, is the general notation for the trapezium rule. And I think right now we're ready to apply it. So let's go back to the first example we've had, wherein we found the area of this. We tried to find, rather, the area of this using the usual way that we've had. We're in integrating the function. But again, what if we don't know the function at all? We are just given the curve. In that case, we will use the trapezium rule. So if you try to look at it, trapezium rule for this is divided into 5 different trapezoids. So the trapezium rule would be, before we go use the trapezium rule, by the way, let's try to find first some of the things that we need to. So here, this is the width, which is just equal to 1 unit. Okay? And what if there is no graph? So to find the width, if you try to look at it, it's the same as finding how wide this is, all right, which will be divided into the number of trapezoids that you are using. So in this case, it's like this is 1 and this is 6. So this is 5 units long, and the 5 units long is divided into 5, or will be shared by 5 different trapezoids. Each of them will get the same width. Each 5 trapezoids will get the same width. In other words, this particular width, which is 5, will be divided among 5 trapezoids, and that gives us 1 unit. That's why we know that this is 1 unit, 1 unit, 1 unit, and so on and so forth. So if you put it into formula for you to be able to remember, so to find the width slash the height of a trapezoid, that will just be the upper boundary minus the lower boundary divided by the number of trapezoids that you are using. And that gives you the width for each trapezoid. All right? Also, let's try to look at the length of each trapezoid for us to be ready. So the lengths are as follows. So we have 12, we have here more or less 6, 4 here. Here is in between, so we just simply approximate it. Also, somewhere in between, and of course 2. Once we know this information, we can now use the formula or the notation for the trapezium rule. So we will be using this one since we only have 5 trapezoids. To continue, so we can now input the values. Now, this is the first length, this is the last length, and these are the ones in between. So if you try to look at it, these are just approximations, so they're not really exact. Okay, now to continue, if you try to solve it, we get actually 21.9 square units. So you might notice that this is a bit different with the answer we got when we do the integral, but as what I've said, this is just an approximate. You could still expect that there are some errors because looking at the figure here, this is overly covered, or there are areas here which are beyond the region we are looking for, the area of the region we're looking for, but is included in the calculation. That's why you could see some errors here. But this is the method that could give us an approximate closer to the real one. All right? That's why we call it an approximation. And this is how we use the trapezium rule. Pause the video, copy the notes if it's necessary. Let's proceed to another example. Suppose we have this particular example. Use the trapezoidal rule to estimate the area under a curve over the interval, okay, with x and y values given in the following table. Pause this video before you proceed. Try to answer it on your own. Analyze well. Try to see what data, what information you need in order to use the trapezium rule. Pause the video now. All right. So again, first we need to find the width, or let's say the height of the trapezoid. The height of the trapezoid is actually based on the x. How far one x value is from the next, or to the next. So we can see here that the height x, which is x, is just equal to 2. So 1 going to 3, 3 going to 5, 5 going to 7, 7 going to 9. It's a matter of 2 units. All right. Now, next. Okay, this one. All right. And of course, we also know that this will be our first vertical length, or this will be our first length, second, third, fourth, and fifth. So in this case, if you try to look at it, we actually have here 5 trapezoids. Oh no, 4 trapezoids rather. 4, not 5, 4 trapezoids. So this is the first trapezoid, first length. This composes the length of the first trapezoids, 5 and 7. And then we have the second trapezoid, this one, third trapezoid, fourth trapezoid. So you could have this as y sub 0, y sub 1, sub 2, sub 3, and sub 4. That's why we can say that there are 4 trapezoids here. So since we already know this information, we can now use our trapezium rule. So we have half of 2, which is your height, times 5, which is the first length, plus 4, which is the last length, plus 2 times the ones in between, 7, 6, and 10. Now, warning, most of the students will use the x values instead when doing this one. That's a common mistake. So they usually commit a mistake by, instead of using the y values for the length, they use the x values instead. So please be careful that here you're referring to the length, which is the vertical length. That's why we use the y values, not the x values. So if you try to inspect, it's 1/2 times 2, which is the width. And then for the rest, it should be the y values. 5, 4, 2 plus 2 times, you have 7, 6, and 10. And thus, you will get now an approximate area which is equal to 55 square units. Take note, since we're talking about area, it must be in square units. All right, pause the video and copy down notes. Let's proceed to the next. All right. Use the trapezoidal rule to estimate the area under the graph of y equal to f of x using the data points given in the diagram. Again, there is no function given, so we cannot use the usual rule or usual method that we do. At this point, pause the video and try to do it on your own first before proceeding at how this will be solved. Copy down notes if necessary. All right. So if you try to look at it, if you try to analyze this one, you're already given the clue that for this particular example, we can actually divide this into 5 different trapezoids. Okay, so we have 1, 2, 3, 4, and 5. And since you're given the coordinates of the points, you could already tell what the y value of this, and so on and so forth. So we now have the y values. What we need to know now will just be their width or simply their height, which is just the x intervals. So for it to be easy, we can just find the width, the total width of the region, which we wanted to find the area, and then divide it into the number of trapezoids that we are planning to create. So the total width should be shared equally among the 5 trapezoids. That's why we need to divide it by 5. So that would now be 4 minus 1, which is the upper and the lower boundary, divided by the 5 trapezoids. That means each trapezoid will have a width of 6.6 units. Since we already know this information, we can now proceed with applying the rule. This will now be half of 0.6, which is your x, times the first y value plus the last y value plus 2 times the sum of the ones in between, 4.32, 3.87, 3.57, and 3.37. And if you try to use your calculators to compute this one, you will have an answer of 11.55 square units. And this is by means of the Trapezium rule. Let's have another example. How about if you are asked to find an approximate value of the integral sine squared x dx from 1 to 4 using the trapezoidal rule with 4 intervals? So in this case, you might be tempted to use the usual rule, but then since the instruction says trapezoidal rule, you have to follow it. You can use the usual rule to just check if your answer is close to the answer derived using the trapezoidal rule. So if you try to look at it, for this to be easy, it's better for us to graph. Okay, so for us to know how the graph looks like, but we know that the boundary is from 1 to 4. So from here alone, we could already compute the width of each trapezoid. And how to do that? Remember, we have to know the total width divided by the number of trapezoids that we are gonna make. So from here alone, we could already predict that the width of each trapezoid will just be 4 minus 1 divided by 4, which is equal to 0.75 units. That's how wide each trapezoid would be. Take note, when I say the width, I'm referring to the x interval, not to the y. The y refers to the length, how long each trapezoid is, how long the parallel sides are. So the width is actually the height of each parallel side. At this point, you should already be able to distinguish the two. So again, the width will just be 4 minus 1 divided by 4. Now, for you to be able to visualize it further, we can actually graph it. So this is now the graph. And since it's from 1 to 4, so again, we can find the height, and that's really 0.75. So we know that one trapezoid will be about 0.75 wide, okay? And so on and so forth, until we were able to divide this into 4 different trapezoids. Okay? To continue, we have to find their specific y values. So for the first trapezoid, if you try to look at it, to find the corresponding y value, we are going to substitute we are going to input its corresponding x. For example, the interval is 0.75, right? That means the first trapezoid will be from 1 to 1.75. So somewhere here, perhaps. So to find how long, like to find the corresponding y value of this, so this serves as your input in a function. To find its output, you need to substitute it to the x value here. So we can assume that the length of this will just be sine of 1 squared. Similarly, the length of the length of the other parallel side, which is having an x coordinate of 1.75, the length of that will just be the sine of 1.75 squared. Meaning, in this case, to find your y value, you have to input a specific x value which corresponds to that y value. Okay? So here, with that kind of analysis, we can now use the trapezium rule with 4 trapezoids, and we can now have half of 0.75, which is the width, times the first one. This one will just be sine of 1 squared, plus the last one is sine of 4 squared, plus 2 times the length of each, which will just be sine of 1.75 squared plus sine of 2.5 squared plus sine of 3.25 squared. Pause the video, try to analyze, try to ask questions if you need to ask questions. However, if you try to put it in your calculator and press enter, you will now get 1.48 square units as the approximate area. Take note, this is just an approximate value. It might differ if you try to put this directly in your calculator, but the difference may not be that much. All right, let's continue. This will be the last example, and after this, I'd like you to do the exercises necessary to be accomplished in this class. Now, for this example, suppose the cross-section of a river in which the water is flowing at 8 meters per second. So this is the speed of this is how fast the water is getting into this particular section of the river. It's getting into at the speed of 8 meters per second. Okay, is shown in the diagram. Use the trapezoidal rule with 7 trapezoids to find an approximation for the volume of the water passing this point in 1 minute. All lengths are in meters. So first, pause this video and try to analyze. Alright, so if you try to look at it, we're looking for the volume of the water that passes through this particular point, okay, in 1 minute. So we are given here that the water is flowing at a rate of 8 meters per second. If you try to look at it, this 8 meters per second is actually how deep, the depth of the water. So every second, that is how, this will tell you how fast the depth rises. So it rises at a rate of 8 meters per second. So that's the depth. All right? And then you are also given that if this is being plotted, somehow we can represent it with these table of values. Again, try to analyze first before you try to look into my video. Okay, so again, we need to find, here we already are given that we are to use 7 trapezoids. And from the video also, from the given also, from the graph, we know that the boundary is from 0 to 7. So we could already find their heights, okay? So the width of the trapezoid that we're gonna make will just be 7 minus 0 divided by 7 trapezoids, which is just equal to 1 unit. However, if you try to closely inspect the video, this will just be 1 unit, okay? So plan it out. How do you find this particular area here? Okay, so if you try to recall our previous lesson, it's like you finding the area between 2 curves. The first curve is the horizontal line, And this is now the second curve. So our plan here is to be able to find this area, we need to find the area first under the horizontal line, then subtracted by the area under this curve. All right, I repeat. To find the area in the middle, find first the area of the region under the horizontal line and subtract it with the area of the curve or area of the region under this curve. Okay, so for the first step, we need to find the area of this horizontal line or the region under this horizontal line, and we can assume that it will just be a rectangle. Okay, that's the area of the region under this horizontal line. So as a rectangle, it will just be length times width, which will give you 28 square meters. So this is now the area under the horizontal line, which is y equal to 4. This is the horizontal line. Now next, we have to find the area under this curve. But since we don't know the function that defines this curve, that is where the trapezoidal rule comes in. The trapezium rule comes in. Okay? So a while ago, we already identified that the height is equal to 1 meter, or the width of each trapezoid is equal to 1 meter. All right? So this curve, this area will now be computed using the trapezoid rule. We have 1/2 times 1 times the first length 4 plus the last length 4. We're looking at the y values plus 2 times the ones in between. 3, 1.4, 1, 2, 3.4. All right. So if we try to continue to solve it using the calculator, we'll get 14.8 square meters as the approximate area under this curve. Now, go back to what we were really looking for at the beginning. We are looking for the area in between the two curves. Meaning, to find the area, we have to subtract 28 by 14.8. And this gives us the cross-sectional area, this portion of this particular river. Is it what we're looking for? Are we looking for the cross-sectional area? Go back to the problem. Pause this video, read the problem again. At this point, you might now have realized that we are not looking for the cross-sectional area, but we're actually looking for the volume of the water passing in this point in 1 minute. Hence, to find the volume, okay, by the way, this is the cross-sectional area, 13.2 square meters. Make sure that you're using the correct unit. So we're looking for the volume. To find the volume, it will just be the cross-sectional area times the depth. All right? The depth of this one in 1 minute. So to find the depth, it should be how fast the water is rising in 1 minute. However, we're given how fast the water is rising every second. So that will just be easy if we are to convert minute into seconds, by which 1 minute is equal to 60 seconds. So in 1 second, the water is already 0.8 meters. If it's 2 seconds, the water will just be 1.6 meters deep. If it's 3 seconds, that will be 0.8 times 3. That's 2.4 meters deep. In other words, to find the depth in 1 minute or simply 60 seconds, that will just be 0.8 meters per second times 60. And the value we'll get is equal to the depth of the water. Having known that, we can now find the volume of this portion of the river, which will just be cross-sectional area times the depth, as what I've said, which is just 13.2, the one we got, times the rate, times 60 seconds. So this portion here gives you the depth. And to continue, we actually will get 634. This time, take note that this is meter squared. This is in meters. That means the unit should be in cubic meters. Cubic meters, which is fit for volumes. Remember, square meters for area, cubic meters for volume. Make sure that you know your units. Okay? And this is how we can use the trapezoid rule or trapezium rule in order to find an approximate area under curves when the function is not given. This time, please do unfinished activity 11D. I'll be checking it today. And also reminders, formative assessment on Friday, which will be area between curves, trapezium rule, and I will also include some integrals. So asking you to find the integral of a certain function. Thank you so much, and you may now proceed.